Wait, who's taking all of our social notes?
It's recording.
Julia's here.
Okay.
Okay, make sure
Hello,
you can see
Brandon.
it. No,
We're
no, no,
in
no, no,
start
no,
class on
Lena.
Monday. What's today's date, class?
The 9th.
The 9th.
It's the
Okay.
9th.
November the 9th. So.
November 9th.
So I've started talking of this chapter about random sampling, and the first one we did was an SRS, but sometimes it's difficult to do that with a large population. So we advanced to what was called a stratified random sample. So how would you do a stratified random sample? You want to divide it into strata or groups. And do you want those people to be like each other or different from each other? How's it work with stratified, the first one we learned? Do you recall, Bailey, how's a stratified layer look like? Does everyone like each other and different from the other levels, or does it work the other way?
Wait, what did you say?
Stratified, how does that work? What does a strata look like?
Each strata looks the same as, like, the individuals in it look the same as each other.
Right.
Like I don't know
Yes,
how to
right?
explain without like comparing it to a cluster.
No,
Right, don't compare it. Pretend we haven't heard of
Okay,
it.
so,
So what you said was fine, though.
okay,
All right, she got the idea.
please get it off me.
All right, we're going to divide the group into divisions where everyone in the group is similar to each other, but the groups are different from each other. So if we were in the school and we want to divide into strata, what could we do, Elena, that where the groups, they were going to be the same in each group? What kind of division could we do in the school, in our school?
What?
How can we break up the school into groups of people that are like each other?
Similar in some way.
Oh, but each group is different from the other groups.
Like classes.
Right, so we have 9th graders are similar to each other, but different from 10th graders, so to speak. And
Not
11
really, though.
like
Yeah.
each other,
We're
and
kinda
12
all
they're
like
like
each
each other. But they're way different from each other group by group, supposedly. So from my viewpoint, they don't look that much different, but from your viewpoint, I'm sure they are vastly different. All right, so we were going to talk about the next one, and that was called a cluster. And we just barely breached the subject to teach what a cluster was. So as you can tell from our discussion so far, it's kind of the opposite of strata. Instead of having everyone alike in one group, they're all different, but each strata is somewhat like the whole population. So, Julia, did you follow clusters when you were reading, or we didn't get
I
it?
was a little confused on that.
Okay, well, you can listen then. Allie, take our school and divide it into clusters. Houses, because in each house you have various populations of grades. So you have 9th, 10th, 11th, and 12th in a house. So the house is varied, and it's very much like the whole group, but it's the division, a smaller division of it. So from that, let us look at the questions in the assignment, because that'll probably fine-tune your understanding of it. So we were working on number 17, and I'll give you a question if you would tell me what the question was and what the answer was. So over to you, Caleb. Take 17. What were they asking about there?
17 pages or so.
127.
No,
I mean 227.
228.
227. Yeah.
Number 17.
Right. So talking about phones. In a factory, there was 1,000 and they want to inspect 20. So your question is about why would it be difficult to use an SRS?
Because
Did you do that one?
no.
Uh-oh. All right, well, I don't want to take time to figure it out. We'll just listen to our discussion. Bailey, why is it difficult to take 1,000 phones and do a simple random sample?
So you would have to number each of them, and then you would have have to keep them in the same order throughout the whole process, and that's 1,000.
Right, just numbering them alone would be a pretty long process
Might
to
as well
number
check that.
1,000 phones. So,
Yeah.
and then you got to do your generator and take, how many did they want? 20? Yeah. All right, so I guess it's the numbering. How can you easily number 1,000 phones? All right, on part B then, Bailey, they want to know, if I just take the last 20, would that be a good way to sample it?
I said no because the quality of the phones could have changed like throughout the day.
Right, so
and
the
at
end, they
of
might
the
be
day-
way worse or way better, I don't
Yeah.
know which way. All right, so what's that word called when you get a sample that doesn't show the correct data? Julia, what were you gonna say?
Bias?
Yeah, that would be a biased sample, exactly. So it's gonna be over or under the actual value that it should be. All right, so Elena, every 50th phone they were talking about. So would that be a good way to do it, to take every 50th iPhone in the factory and just test that? Would that be SRS?
It's not an SRS.
It's not. It's nothing random about that. Random is random. It doesn't happen in any pattern. So here's a very clear pattern. So sort of like if a worker knew, well, the 50th phone is going to be, so I'm going to work real hard on the 50th one, but 1 through 49, I'm going to slack, you know. So you don't want to have any predictable pattern. So, and the other 49 have no chance of being selected. In a simple random sample, every individual has an equal amount of chance of being selected. All right. So, Julia, was 19 one that you were successful on?
No.
Pardon?
No.
Okay.
I
Well,
did 17.
all right, sorry. We
It's
passed
all right.
that one. All right, on 19, could you explain how we would find that in your own words? Allie, how you would use the, what do they want, the random
The random.
chart?
Yeah.
All right, how does it go?
You would assign each of the students 1 through 30.
Okay, it's
in order.
faculty members, but whatever.
Those
Oh, no.
Those are students that you
Oh,
assign
it's
10
first-
faculty members.
Oh, you're
1 through
right,
10.
you're right. I'm looking at the bottom. Go ahead.
Okay. And then you would assign the faculty members 1 through 10.
Okay.
And then you had to go to table D at line 123
Uh-huh.
and find.
All right, now fine tune what you said. You said 1 through 30. What actual digits are you talking about?
0, 1 through 3, 0.
So you're using
Zero.
2-digit numbers.
Yes.
All right, and also for the faculty, how would you do that?
Maybe 1 through 10 using 2-digit numbers.
Okay. All right, so make sure that they're always the same number of digits or the random chart isn't going to work.
Wait, 1 to 10 using two digits.
So you have to
Wouldn't
do
it be easier
0,
to just
1,
do
0,
0 to
2, 0, 3.
That's what I did, is 0 to
Wouldn't it be a lot
9.
easier to just do 0 to 9?
Yeah, either way.
Okay.
So whatever works for you, you can use 1 digit. Then you go through the chart even faster. Yeah. All right, but it would work the other way.
Brandon!
All right, Brandon, over and out.
Goodbye, Brendan.
Bye.
Say goodbye to Brendan.
Okay.